Thank you, Andrew. Time now to check in with our Richard Desjardins, who is at the Schulich School of Music. Good morning, Richard.
Good morning, Paula.
You don't look like you're in the Schulich School of Music.
I'm right
You're
beside the Schulich School of Music. We're going to be going in a little bit later on. So, Paula, musicians move when they play a piece of music. You know, they move.
Yes.
9 months later, do you think they move exactly the same way or they move differently if they play the same piece of music?
I would say they move differently.
They move exactly the same.
Really?
That's one of the things that Professor Marcello Wanderley is studying. He's the director of a laboratory here at the Schulich School of Music called the Input Devices and Music Interaction Laboratory.
Oh,
and another one of the interesting things he does is they make experimental musical instruments. This is a musical instrument.
What is that? And what do you do with it?
It looks like a pipe that brings hot water
to your... someone on the head with it.
To your whirlpool bath. Yeah, you clunk someone on the head with it. That'd probably make an interesting sound.
It probably would.
This is called a T-stick, and it was developed by one of the PhD students in music technology who are in Marcello Wanderley's lab. They've got a lot of other weird instruments too, including a gyro tire and another one. I can't remember the name of it, but it's actually, I think it's a meta instrument that you actually wear.
Wow. Are you going to wear one later on?
Yeah, I'm going to try putting it on and make some sounds with it, too.
Well, that sounds like it's going to be a whole lot of fun, Richard. I can't wait.
Is that a pun? It sounds like it's going to be fun? Sounds? Get
sounds, yes. Ha.
Funny.
All right, you get inside and get warm. We'll see you a bit later.
Okay.
All right, thanks, Richard.
Good morning. I don't know how often musicians can say they wear their instrument, but this is actually a meta instrument. The music that Joe Malik, a PhD student in music technology here at the Schulich School of Music, is holding is called a T-stick. It's a music that an instrument that he's developed. We are actually in the Input Devices and Music Interaction Laboratory here at the Schulich School of Music, and we're going to be talking to Professor Marcello Wanderley about why he studies the relationship between movement and music, and where all these very interesting musical instruments come from later on This Morning Live. Wish it was making sound. Only Joe's is.
And good morning. Welcome back to This Morning Live. Time now to check in on Richard Desjardins, who has been spending the morning at the Schulich School of Music checking out some really interesting instruments. Good morning, Richard.
Good morning. The Schulich School of Music has an Input Devices and Music Interaction Laboratory. That's where we are this morning. Professor Marcello Wanderley is director of the laboratory, and in the background you can see PhD student Joe Malik. He's getting his PhD in music technology. My first question would be, why does the Schulich School of Music need a laboratory like this? But I think I'll start by asking you what you do here, and you may answer my other question along the way.
Yeah. Basically what we do here is study new ways to play musical instruments, right? So create new musical instruments. And the idea is that the computers today, even cell phones or whatever, that's small computers, they can play sounds that by 30 years ago, just like huge computers could do. So how can we play these devices as instruments? So we design these interfaces that we connect to the computer and try then to play these interfaces. So for instance, the T-stick that you can see Joe playing now. It's a new device that he developed with some colleagues, and the idea is that he can then use this to control the computer and create the sounds in the computer. Right? So the question is then, how do you play such a thing? Right? It's not related to any existing acoustic instrument, right? Yeah. So there's a lot of electronics, computer science, and other disciplines involved. But there's also, of course, at the end, that's why we are at the Schulich School of Music, is the musical part, right? Can we get this to be as expressive, let's say, or as satisfying as acoustic musical instruments?
Another thing you do here, Professor Wanderley, is study the relationship between motion and music, the way musicians move.
Yeah, we do this in both for acoustic instruments and for electronic ones. So for the electronic, or these guys you see there, is to understand really what strategies people use to control the sounds, right? But in the acoustic ones, we want to, for instance, understand differences in performance. For instance, two cellists are playing the same piece, they don't play exactly, do their movements change? Mm-hmm. Or their movements is exactly the same and it's a different just on the instrument, whatever. Of course the movement changes, but we want to quantify that.
Yeah. What's the advantage of quantifying that?
Well, we can then use for pedagogy, like for instance, learning why people should or shouldn't do certain types of movements. We can prevent perhaps, fatigue or different problems musicians may have. And of course, we can maybe, for sure, we can try to better understand the question of expressiveness in performance. Mm-hmm. I mean, is it due to the movements and what is done or not? Yeah. Styles, schools of learning, etc.
When you go to a party and people ask what you do, how do people react to this kind of stuff?
Well, it's a big question because I think McGill is unique. Actually, it's very few places, if any other in Canada. The idea is that we are engineers, actually, in the Faculty of Music. So this is, I think, very, very strong because we are not musicians, but we collaborate with the musicians. So by doing this difference between technology, by being very clear on what we do, I think we built bridges, right? About, then we create with composers and musicians, we do really musical. But basically, I'm an engineer working on sensors and electronics.
Wow, neat. Professor Wanderley is director of the Input Devices and Music Interaction Laboratory. When we come back, we'll talk to Joe about how he gets the instrument to do what it does and how he came up with the idea to make the instrument.
All right, thanks very much, Richard. And now good morning and welcome back to This Morning Live on this Tuesday, cloudy, dreary morning. Time now to check in with Richard Desjardins, who is getting a lesson on cool, interesting instruments. Good morning, Richard.
Good morning. We are at the Input Devices and Music Interaction Laboratory of the Schulich School of Music. Professor Marcello Wanderley, who you see in the yellow shirt and the weird things on his hand, is director of this laboratory. Joe Malik, who's standing beside me, is a PhD student here, getting his PhD in music technology. And we saw him last half hour playing these instruments, which are called T-sticks. Explain, well, let me start with, what is it? Yeah. But just how you got into this field, first of all, before we talk about the instrument.
Well, that's a crazy story, I guess. Not that, well, many of the people here in music technology actually have backgrounds in engineering or computer science. Although we're part of a music faculty, it's very kind of multidisciplinary. My background's actually in music, so I feel like I'm the odd one out a little bit, but I'm learning lots of engineering kind of as I go along. I mean, this takes a lot of kind of knowledge of electronics and stuff like that in order to really design an electronic instrument.
What's your musical instrument?
Trombone and piano, actually. Yeah.
So does this relate at all to a trombone?
No, maybe a little bit. I mean, it all relates. I mean, it's all music, so you might think that when you design an electronic instrument, you have to completely reinvent everything, but really that's not true. I mean, people have been inventing instruments for thousands of years, and there's lots of kind of commonality between them all.
This is called a T-stick. Explain what it is, how it works, how you came up with it.
Okay, well, it was called the Tiger Stick first, but now it's the T-stick. It has stripes underneath the rubber coating of copper, and those form sensors that can sense where you're touching it, actually, using capacitive sensing or electric field sensing. So we've all heard about multi-touch sensing because of the iPhone and stuff like this. So this is actually a 2-year-old instrument that has multi-touch sensing, and it can tell where you're touching it and also how much of it is being touched, as well as things like tilting and shaking and twisting and pressure and pretty much everything that you do to manipulate the physical part of this. All that information is captured and sent to a computer, and we can use that to synthesize sound.
Okay. When will the first concerto for T-stick be written?
Well, there's already been solo pieces written and performed for the T-stick, so it's been performed about 4 times, I think, now. And it's actually been taken down to San Diego and performed there, and I showed video of it being performed in New York, though it wasn't actually performed in New York. And then this coming March, there will be pieces that use 2 of these T-sticks together for the first time, because it was only solo pieces before. Okay. So it's coming up.
So there are T-sticks. Are there T-sticks elsewhere in the world?
Not yet.
Okay.
Not yet, but I think there will be. We're working on it.
Yeah. So actually, musicians could be able to sit down together and play and perform.
Yes, definitely, yeah. A big part of this project with the T-sticks is actually to build a family of instruments that are complementary rather than having, several copies that are exactly the same. So you can see I have like the alto version and the tenor version of the T-stick here, and I'm working on building a soprano and a bass, and then at that point I have a quartet, sort of like a string quartet except of electronic instruments.
Wow. I don't know whether to think that it's incredibly exciting or incredibly daunting to start from zero with a whole new instrument.
Well, it's definitely both, but like I said, I think it's very important to remember that you don't have to actually reinvent everything. That this is part of kind of a continuous evolution and of musical instruments where people are always building new things and experimenting. Yeah. So we can always kind of use the experience of past instrument designers.
Joe Malik is a PhD student here, and Elliot Signor is just finished his master's. He's got an instrument called the gyrotire, and when we come back, we'll hear that.
I don't know about those instruments. It sounds like whales.
I know, but
singing in the
whenever
background.
you hear PhD student or master's, you just think, wow.
Yeah.
Just
I
the
think, you know what, I
time
think
that
we
it
can make up,
takes.
get an instrument out of those 2 mugs.
That's right.
And time now to check in with Richard Desjardins, who has been spending the morning at the Schulich School of Music. Good morning, Richard.
Good morning. We are at the Input Devices and Music Interaction Laboratory of the Schulich School of Music, and now I'm joined by Elliot Signor, who just finished his master's and has come up with an instrument called the gyrotire. And yes, you are looking at a bicycle wheel. How, Elliot, do you come up with the idea of turning a bicycle wheel into a musical instrument?
I was taking Marcelo's seminar a couple years ago, and it actually came to me. We had to come up with a final project that used sensors to basically make an instrument and then control a computer with it. So I was on a train actually when I came up with the idea, and I was listening to like the wheels were going around and around, and it just seemed like it would be a fun way to explore using a wheel in different ways to control different sort of musical processes. That's where it came, and then it was a matter of putting sensors on it and then trying to control different kinds of sounds to see what would be interesting. And yeah, just as they've probably mentioned, just computers can make so many different types of sounds that trying to control with a keyboard and mouse is just ridiculous. So decided why not try a wheel.
So explain how this works. There's a little sensor here, and each time it goes by...
Yeah, there's a little sensor here.
Okay.
So when this guy crosses these 4 little drums in this case, so this is one kind of obvious thing to do.
And you can move the sensors around to get different beats.
You can move the sensors around to get different beats. I'm not going to do that now, but you could also turn one off. Let's say I'll turn the snare off, or the bass drum actually. There we go. So that's one of the ways it can be used.
Then you have another one called the arpeggio.
Yeah, this one, there's this little toy instrument called an omnichord that inspired this one. It's kind of this, I think it's made in Japan, and you kind of strum it and it plays arpeggios. So I sort of took that and applied it to this. So here we go. So the speed of the wheel is how fast it's going. Let's see how fast we can get it. There we go. And then the octave is basically what angle it's at. And then you can change the key. Like that.
What would you like to see for the gyrotire in the future?
I don't know what I'd like to see. It was more of an experiment to see how it can be done. Oop, there we go. It's more along the road to getting a way to control computers to make music, basically. So this was just one way. I don't think there's going to be thousands of them and everyone will be playing them. But
why not?
It'd be nice. Yeah, maybe. I could try. I'd go into mass production and be funny.
Yeah, no, it's pretty neat. How do people react to?
I don't know. Some people are just kind of mystified. They're like, well, how does that work? And then explain it. Yeah. But most people seem to enjoy it. They like to see something moving. Right?
Yeah. No, it's pretty cool. Elliot Signor just finished his master's in music technology here at the Schulich School of Music. It is called a gyrotire. They have all kinds of neat stuff here. You can check out their website. This is actually invisible drums. Pretty cool. The director of the lab is Professor Marcello Wanderley. Thank you very much, Professor Wanderley, for letting us visit.
Well, thank you for coming, and again, check the website.
Well, if you've had trouble trying